Hello. Great. Let me check if the online stream is on first. Moodle. Damn. How's everybody's experience using Moodle? Because we got like a survey about the type of technology we use in CSE. Apparently, we have way too many platforms. Like we got Ed, we got Moodle, and we got WebCMS. I personally, I feel like, anybody used Ed before in a CSE course? Ed, ED? How do you think of it? I feel like, I personally I prefer Ed over Moodle because I feel like Moodle is just kind of hard to navigate. And Ed actually have like some online servers where you can run your code and then you can do auto test. So that's the part where I like, which I like. And WebCMS is obviously the best because we designed them. This CSE designed them like a couple of years ago. Great. Right, welcome to, hope everybody got a good weekend, and welcome to week 5. So we got a couple of announcements to make. So first assignment is due this Friday at 9 p.m. And we strongly encourage you to test your code well before the deadline, because every year towards the deadline, the server gets very busy, and then the running time will be slow for your code. So for instance, if you run your code now, it could be like 3 seconds, but towards the end, everyone is using that server, and then you could end up with 2 minutes, and then you're wondering why. Another thing that we need to mention about the quiz is, I think most people have no issue with this. I know I mentioned we're kind of flexible on, like if you have a problem with quiz, you can email us. But I want to make a clarification that we got some emails like right before today, and they're asking if they get an extension. The bottom line is you cannot do that. You cannot have an extension if we have like the answers released the next day. So let's say that you missed your deadline on Friday, and you email me, and then I say, okay, before the answers are released, we're happy to make accommodations because things happen in life. But after the answers are out, there's nothing we can do other than making a completely new quiz just for you. But we're not going to do that after quiz 1 anymore, so just be sure you catch the quizzes. And today we're going to talk about how to connect to PostgreSQL from Python. So this will be super important for the next assignment, obviously. So up until now, we have talked about data manipulation language, data definition language, and everything that is wrapped in SQL. And after that, we also talked about PLPG functions, SQL functions. But there's a way for us to connect to the application layer. And nowadays, most of the application layer is written in Python. And even if it's not written in Python, these libraries, they can, they're also available in other programming languages as well, like C#, C++. And so basically, the overall idea of how to connect to a database from the application layer will remain the same. And in this course, we're just gonna let you guys experiment with Python because this is a database course. We don't want to bother you with like super complex programming languages, so we went for Python. So we don't want you to debug C++ or Java code just because you want to interact with the database. Obviously, you need to have a Python library called CyclePG2. So that's the whole main character of next couple of weeks before the next assignment. So basically, we're going to use the CyclePG2 library from Python, and it allows us to establish a stable connection from the database. And we can basically connect to the database, run some SQL scripts over there, write some SQL code over there, and fetch the data to Python, and then we can do some other processing. And one thing we need to, if you look at this picture, one thing we need to make a note about is that fetching the results from the database is actually super expensive, especially when you have much larger database in industry. So the good practice is that you figure out what you need from the database well beforehand. So you're figuring out like what view you're gonna get, what function you want to call in the database, and then you just make one call, or maybe a couple of calls from the database to get that data, and then you can process that data in Python. The bad practice, unfortunately, a lot of times done by beginners, especially when they're working with very small database and they cannot see the performance drop, is that they always connect and disconnect from the database. So that is like super expensive. That's super time consuming in real life because transferring that data from the database layer to the application layer is the dominating cost of this process. So we want to limit this fetch as much as possible, and we want to figure out what we need to fetch from the database beforehand. And after that, we can kind of do object-oriented programming in Python, which is what it's good for. So I'm not sure if we're going to need this, but we're going to do it anyways. So we're going to have a brief recap of Python. And we're going to do a couple of demonstrations. So we're going to review Python data types, control flow, how to pass in arguments, and most importantly, how to, the most irrelevant part of Python for CyclePG2 is actually how you're going to unpack things into a Python variable. For instance, you're going to fetch some rows, and then how do you unpack that row into a bunch of variables, which you can use later, or you can unpack that row into a dictionary, where you can use that as an object. So I think it's a good time just to do some, okay, this is the wrong server, okay. Okay, this is the right server. So all of the files that we have, we're using for demonstration, they're available on the server as well. You can play with them now if you want. So we're just going to go through a couple of Python examples. So Python types includes integers, floating point numbers, and strings. And let me see if we can get a good example to run. So we have a couple of built-in data structures, and we have lists, and we have tuples, and we also have dictionaries. And the most important data types that are relevant to this lecture, I think, are tuples as well as dictionaries. And we'll see why in a few minutes. So dictionaries are super important. So basically, they're storing key value pairs. And underneath dictionary, there is a hash table to make this key value pair look up in constant time realistic. So basically, they have a hash table to hash all of the keys. And that way, if you're doing the lookup, if you're looking up a key in a dictionary, it's constant time. So things like this should be covered in like a data structure course. So, and you don't have to worry about the time complexity at this point, but you should be able to know that looking up keys in a dictionary is fairly quick. And so these are some Python keywords that you should not name your variables after. So now definition, if else, while loop, for loop, try, except. And print statement, I think everybody can write print statements. And more fancy way to write print statement is that you put everything into an F string, and then you put parameters in the F string, and you can control what is actually, so you can control like the precision of the numbers and stuff like that. So it's just a way for you to control what you print. So the not so fancy way is you just print everything, or you can format them into a F string, and then in here you can do percentage sign $s, percentage sign $n to indicate this, you're concatenating an integer, concatenating a string into the F string. So if statement, while statements, not very interesting. I think most people should understand this before they take this course. So if you're not super familiar with Python, and if you didn't take an CSE course before, I strongly encourage you to learn Python, just the basic stuff. And the reason we chose to use Python as the application layer in this course is because Python has a very good object-oriented flavor, and it's not like super complicated like C++. Because in Python, we can kind of do object-oriented programming, but we don't have to bother with things like destructor, constructor, memory leakage, like we do in C++. So it gives us a balance of both. It's not as fast as C++, of course, because we have less control, but object-oriented programming is what we look for, because at the end of the day, we got entities represented as rows, and now we want objects to represent those entities. And we want to use a style like object.method or object.attribute to manipulate the rows that we have fetched. So this is the whole reason we use Python, because we can do object-oriented programming from here. And this is something that is very hard for us to do in PLPG SQL. So in PLPG SQL, we can still do the while loops, the for loops. We can do procedural programming, but it's very hard for us to do object-oriented programming. And you probably need to import these modules, so the system module and the CyclePG2 module. And later on, I'll show you, you'll probably need to import another extension of CyclePG2. So just import them before you write any code to interact with the database. So I'll show you two ways to fetch the rows. And the good thing about Python is that I think most people know this already. Python also has an interactive shell that we can play with, just like PSQL. And if you want to test something, if you want to write a piece of code that you want to test, and you don't want to write the whole thing, you can write it, and then you can copy and paste that into Python shell, and then you can see the end result. So obviously you can use that for debugging, and you can use that to check whether you have certain packages like CyclePG2. And in C, we have a main function, and in Python we don't bother with the main function, so we have a system.argument list. So this is a Python list of strings, and this is how you can pass in arguments in Python. So to do that, we always need to import the system module, and then we can parse the input argument via index. So it starts from 0, so sysargv0 is the first one, and 1 is the second one, so on and so forth. And let's demonstrate some Python scripts you should probably know how to write already. So we're going to demonstrate them fairly quickly. So how to add two numbers, and how to behave like echo, and how to do the factorial of numbers. And so if you want to add things up, so first we take into arguments, and then we cast them into integers. In the end, we print a plus b. So that's like intro to programming something. And so this is a list containing the command line arguments, and 0 is reserved for the script name, and from 1 to 2, they're the actual input parameters that we put in here. So we're going to demonstrate them in a bit all together, because I think this part should be on the easy side for our class. And how to behave like the Unix echo command. So in Linux and Unix systems, we have something called echo. So basically, we can do echo high class, and then it will print that for us. And we can implement that in Python in this way. So basically, we're going to go through everything after the script name, and then we're just going to print it. So that's not. And then we can also implement a factorial function. So we already know how to implement that in PLPG SQL. So this should be super easy as well. So we just got one input parameter, and then the input parameter is n, and now we need to compute the factorial of n. And obviously, there are two ways to compute the factorials of n. One is the recursive function, and the other one is the iterative function. So we don't bother with recursion right here, because this is just demonstration. We're just going to use a for loop actually to get the factorial of n. And let me demonstrate all of these in a bit. And if you happen to don't know how to do them, please take some time to learn Python. So add things up, and what else we got? We got factorial. So basically, there are a couple of ways you can run a Python script from the terminal. You can put Python 3 up, and then script name, and then arguments. Or you can you can make it to be executable, and you can put shebang in the beginning of the script, and then you can basically run the script just like you run a shell script. And what else did we need? Echo. Okay, echo. So we're gonna do echo, and then we're gonna do today is a good day. It's a good day. Okay. So basically, it looks at all of the so echo.py will be the argument of index 0, and then today is the argument 1, and it will just print out, it will just repeat everything from 1. So, okay, that's enough refreshment of Python. Now let's let's dig into the actual important package, CyclePG2. So in CyclePG2, we'll learn how to connect to the database. We'll learn how to create a cursor to go through each row of the result that we have fetched. And we'll learn how to execute a SQL query. And then we're going to learn about the good practices and the bad practices to prevent SQL injection. So when we're writing, so most of the security part is handled by the SQL engine. It is already handled by the SQL engine. And as people who are using SQL to write queries, this is pretty much the only thing that we need to worry about, which is how not to write code that allows SQL injection. And after that, we're going to do some examples of fetching from the database and processing them. So CyclePG2, this is a library for Python to PostgreSQL interaction. And so basically, we use CyclePG2 within Python, and then it will handle all of the authentication and connection for us. And we basically feed SQL queries via CyclePG2 into PostgreSQL, and then PostgreSQL will listen from CyclePG2, and it will return us the tuples. And PostgreSQL is just another layer on top of the actual database, which is a bunch of files, a bunch of indexes on disk. So we don't have to worry about these green arrows here. So these are already handled by PostgreSQL language. And so in the next couple of weeks, we're just going to focus on how to interact with PostgreSQL in Python. So these are the most important syntax in CyclePG2 you use repeatedly. So the first one is super important. You want to open a connection to the database, and you want to close the database connection. So what we have seen before is that in a small database, I think I've mentioned this, a lot of beginners, they like to write connect statement as well as close statement within the for loop or within the while loop. So in that way, they're basically saying, for each row and then for each task, I am connecting to the database, I'm disconnecting to the database, and then I'm connecting to the database again, I'm disconnecting from the database again. So they're doing this over and over again, and that's not a intended way of using CyclePG2's connect. So usually what we do is that we figure out what database we want to connect. We just connect once at the beginning, and then we just close in the end. And in the meantime, when we have intermediate results, in case you want to do insert, update, or delete, you can use commit to save these changes to the database. And for the purpose of the next assignment and most of the scenarios where you use CyclePG2, most of the times we're not asking you to change the database. We're asking you to do queries. So we're asking you to ask questions about the database, read from the database, maybe call a function from the database, things like that. And so that's about connection. So just connect once and close once in the end. Don't do this. Don't overdo this. And then is the concept of a cursor. So cursor is just kind of like a pointer on the rows of the results. So you can initialize a cursor, and then you can let the cursor to point to the end result returned by PostgreSQL. So what you can do is that you will pre-write a SQL statement, like select everything from the student enrollment table. And then it will go through that layer, and then PostgreSQL will receive that message, and it will return you the whole table. And then cursor will be on the first row of that result. So, cursor mongrify is a very useful syntax for debugging. So it's not running anything, but it's showing you the actual SQL that gets sent to PostgreSQL. Because notice that when we're executing this, we're also inputting some values. So those are the parameters that we could be using. So sometimes we're executing a SQL query more complex than selecting the whole table. Maybe we're selecting John's favorite beers. So here we could be saying that select everything from beers where the drinker matches John, and then we put John's name in here. And that becomes a parameterized query. And after that, how do we know if this is the SQL query we have in mind? So we could be wrong, right? So the way you can check that is you can do cursor mongrify. So it will actually print out the SQL query after you put that value into the SQL statement. So basically here it could be a bunch of SQL string with placeholders, and then values will be the actual maybe drinker's name or student ID, and then the result of mongrify, it will show you the actual SQL query that you send to PostgreSQL. And there are a couple of ways to fetch the results. And after PostgreSQL receives our message and return our results, our cursor is at the first row. And depending on what you need, you can choose to fetch all rows, or you can choose to fetch one row, or you can choose to fetch the number of rows you want. So in the beginning, it is at the top. So if you just fetch one, it will return the first tuple from that result. Or if you want to actually do the enumeration within Python, you can store the result of fetch all into a list, and then you can use a for loop to go through that list. And of course, if you just want like maybe 100 of them, maybe 5 of them, you can use fetch many. So most of the times, this syntax will be enough for you to play with CyclePG2. And beyond that is just basically how you formulate your SQL statement and how what parameters you choose to put in there. So to begin with, you need to open up a connection. So before this, you should have imported CyclePG2 module, and after that, you can establish connection. And the connection name here is the DB connection string. And many beginners, they make the mistake, they just put the database name in here. So for instance, if you have a database named MyDB, you cannot just put MyDB here. You need to say DB name equals MyDB. So that's how you can connect to that database. Otherwise, it will throw an error. And then you can just initialize the cursor like that. So these are basically, these are some type of code you can basically reuse over and over again. And after you're done with everything, you can do connection.close in the end of the script. So this is an example of how you connect to the database, and if it's not successful, it will print an error message saying that, hey, I failed. So so basically, this is a way of catching error in Python. So this is a more robust way of writing something. You can try something, and then you can catch the error. So let's try this. So let's see if we have the database. OK, we need to start the database. Make this larger. OK. We have the MyDB. We have the MyDB database. Let me look at it. I think MyDB database is a very small database that has like some course enrollments and we have the R table, and we have subjects and things like that. Okay. Now we need to demonstrate the connection, how to establish a connection. So let me just write there. Let me just execute that, and it will see that you will see these two results. So basically, what it does is that it establishes a connection from the MyDB database, and then it will print the state of the connection after you open it. So at that point, it's not closed. So basically, this indicates that we have a legitimate connection. And after that, we just close it right away, and then we can print it. It will show this is closed. So that's how you can that's how you can establish a connection from a database. And the takeaway is you need to. So this is where people make mistakes the most. They just put MyDB here, and then they tell us, "Hey, I cannot connect to the database." So you always need to put DB name equals your actual DB name. And you can always use, this is how you can handle transactions and commit. So if you're going to execute some operations that actually modify the database, like insert, update, or delete, after that, you can do commit, and it will send a message to PostgreSQL database, and then it will treat everything before that as one transaction, and then it will actually update the database. Otherwise, the database is not really updated. And the Mongrify, as we have seen before, we have talked about it before. Mongrify is how we can show the actual SQL statement that gets fed into PostgreSQL. So we could be doing what we could have done is that we're doing cursor.execute, select everything from SQL where ID matches something. So this is a SQL statement with a placeholder, and then we need to put 1, 2, 3 to replace this placeholder. And to actually understand how this, what is the actual SQL code, we can use Mongrify to do that. Let me see if we can do a example. So I think it's easier if we just use a Python shell. So first, we're going to import this CyclePG2, and then we're going to connect to MyDB database, and let's see if we change this to execute. So if we execute that, I think the students table is there. Is there? Let me change this to execute and see what it does. Execute. Okay. So cursor now has executed this query from the students table. And how do we actually fetch a result from the cursor? Well, we can check fetch 1, or we can fetch everything. Let's just fetch 1 because I think there's only one student with that student ID. Okay, we need to actually use something to store it. Looks like nobody has that student ID. Let me check. Let me just execute the whole thing and see if we fetch everything from the students, it should give us all of the. It should give us the whole table, the students table. Fetch all, and looks like we only got 3 tuples. And if we just do fetch 1, equals cursor depth. Let me go back and see the actual database. So my DB, okay, we got course enrollment, courses, and the students. Let me see what are in the students table. Okay, yeah, that's basically it. We only got like 3 students with 3 IDs. So that's why I only got like 1, 2, 3. And let me see what other tables we got. Subjects, we got 3 subjects, great. And let's demonstrate how to, let's demonstrate these 3 functions. So basically we can fetch 1 code from subjects, we can fetch all codes from subjects, and we can fetch probably 2 codes from subjects. Let me just make sure that subjects is not empty. Subjects not empty, great. And let me exit local storage. User P1, okay. Okay, Python 3, great. Let me copy them and paste them in here. Okay. And if we do fetch 1, it should give us the first row. If we do fetch all, it should give us, wait, fetch 1 also gives us all 3 rows. I think there's something wrong with our fetch 1 function. Let's just go back and look at it. So fetch 1 function is actually having a while loop going through all rows, and then it will just print everything. So this is not fetch 1, this is fetch everything. And fetch all function is actually performing well, is executing, is fetching all result from the subject code, and then it is setting the cursor to the right place, and then it stores everything into rows, and then we're printing the rows in here. So the difference is that fetch 1 is actually retrieving 1 tuple at a time, and fetch all is retrieving all tuples and store them into rows, and then we go through the rows. So that's how they're different. So basically, the difference is that fetch 1, we're going through all of the rows, and then we're printing them, and in fetch all, we're storing all of the result into a list, and then we're going through the list. And when do we need to use fetch 1 and fetch all and fetch many? Well, if we just want 1 row, or we want to process things row by row, then we can use fetch 1. We only use fetch all when we have a very small result set, because we're getting everything at once. So a very bad practice when you're using CyclePG2 is that a lot of times what students tend to do is that they want to fetch every table from the database. Like we have students table, we have enrollments table, and we have probably course table. What people end up doing is that they fetch everything from all these tables, and then they store them into a bunch of dictionaries, lists, and then they do all of the processing in Python. The bad thing about this is that this only works on very small database where the select everything is possible and is not expensive. So try not to do that in the actual assignment, because we'll probably test you on a much larger database, and then your code will break. And we have looked, up until now, we have already looked at a couple of ways to unpack the result. And so let me go back here and see what we did here. So here we are fetching, we're storing everything that we have fetched into a list, and then we're going through the list, and then we're using the indexes of the rows to get the columns that we want. So this is actually not very convenient, because if we have a very large table, it's very easy for us to lose track which column is column 0, which column is column 1. So I was coding up a database for a finance company before, and this is what I ended up doing. I ended up doing something like this, and they have like 20 columns because they have like they're doing analysis for other companies, so they have like a huge header of the table, and they have many columns. And then for me to generate a report to update to the website, I ended up doing something like, for each row, I need to process row 0, row 1, row 26, and then I have to memorize row 26 is actually their revenue, row 27 is their liability, so that was a nightmare. So when the going gets tough, you probably find this not very helpful. So it makes sense for us to talk about how to unpack things when the table gets large. So there are a couple, basically, the gist is that there are two ways to do it. One way is, let me get to the actual part and give you an overview first. You can first define you can define the things you want and then basically unpack them like this. So let's just say that you only want the first 3 columns, and then you can just define them as code, name, and UOC. And then you can basically manipulate these variables however you want. You can do post-processing on them, you can put them in a nice and F string, whatever. And so this is the one way of doing it. You can unpack it into variables. And another way you can do is, when you have many columns, what you can do is that you can unpack your row into a dictionary, and then the dictionary will have column names as keys, and you're basically doing row equals a dictionary, and then your dictionary can be used as, the instance of that dictionary can be used as an entity in the object-oriented manner. You can basically do subject.code, subject.name, and subject.uoc. So the way you do that is that you can import a dictionary cursor, and then you can fetch everything into a dictionary, and after that you can use it like this. So a row is basically, now a row is a dictionary that stores the code, name, and the UOC from the table. And after that, you don't have to memorize which column is code, whether the second column is name or the third column is UOC. You can basically use it in an object-oriented manner, which is much more easier for application layer programming. Okay, let's take a break for 10 minutes, and after that we'll do a demonstration of how to do tuple unpacking in both ways.
join players be on? Join insertion loading.
All right, let's go back to the lecture. So we've talked about how to use fetch one, fetch full, fetch many to get a result from the SQL code we executed in PostgreSQL. And now this is the important part. This is very, this is where people get a lot of bugs, and I'm really trying to make things easier for you so that you can write clean application level code when interacting with the database. So when you talk about tuple unpacking, and so before we were able to get just one tuple, and what we ended up doing is that we establish a connection, we tell them what SQL statement we want to execute, and then we just fetch the first row of that, and then we need to work with a tuple like that. And the best thing about this is that if you want to get, for instance, if you want to get like the course name, then you have to memorize it is of index 1, and then if you get the UOC, you have to memorize its second. And when this thing gets too long, you lose track of what you want to get. So this is kind of like a bad way, you can say, especially when there are too many of them. So you have to memorize code is the first one, name is the second one, UOC is the third one, and you have to do all that. And slightly better way is that you can unpack these tuples into a bunch of variables, and you can then manipulate those variables like this. So it is slightly, the difference is pretty slight, but it will actually make your code cleaner. So basically, for each row, you're unpacking it to a bunch of variables, and then it will basically put the first value to code, second value to name, third value to UOC, and so that you don't have to memorize which position is which column again when you're using them. And this is slightly better than using the index, and you can still do post-processing based on these values. And however, when we have a much bigger table, this approach becomes hard to track as well, because we end up with like so many variables, and then when we have like many different types of entities, we could have different IDs, we could have different names, and it's very easy for us to get mixed up. What name is it and what ID is it? So the recommended way, if you want to unpack with many columns, is that you can use a dictionary. So this is what happens when we have too many columns. So I'm not going to demonstrate that because it's going to be a mess. So you have to, if you're going to unpack things into these many columns, and then for each row, you need to actually define all these variables that are specific to this entity alone. So for each entity, you're defining about like 10 variables. And then if you have another entity with the same column name, then you're essentially using the same variable for different things. So that's not very good as well. So what I'm saying is that this is a subjects table where we have name. And then what if you have another students table? We have name as well. And then we have a course table. We could also have name. And then although the scope of these variables are different, but it is super confusing for developers. So the better approach is to always use something called a dictionary. So this is implemented in CycleBG2, and I've checked that you can actually use it in our VXDB environment. What you should do is that you should import CycleBG2 first, and then you should import this real dictionary cursor. And just like before, you need to establish a connection, and then you need to add this line. So you need to make sure that the end result is a dictionary, instead of a normal tuple where you have to fetch things via indexes. So let me show you the end result of this, and then let me show you a more concrete example. So here we're fetching everything, and the way we print them is much easier to write. So each row, we're expecting them to already have the shape of the query result, which has all those column names as keys. So now we can use row, we can access these values by putting the keys in there, and then we can kind of do an object-oriented programming like this. So let me give you a one row example. So let me just say that I want to fetch one row. If I want to fetch one row, and now row is just fetch one from this SQL query. What it does is that it gets this giant table, fetch three columns, and then now it is set as the first column. And now the good thing about row is that, so this is the before way. So row is just a tuple, so you have to access things like this. So if you do it in the dictionary way, the row will end up being a dictionary. So this is a real dictionary row, which is easier to manipulate because this thing alone contains not only the values but also the column names. So you don't have to ever need to remember which column is the course name, which column is course code. So if you need course code, you can just do code, and it will give you COMP3311. If you just do name, and it will give you database systems. So as you can see that this is more robust, especially when the table gets very wide, where you have many, many columns. And this will probably save you some time when you're doing the assignment. So let's demonstrate this via another example. So we want to get the subject's details from MyDB. And in this case, this is a fairly easy case where the subject, we're only working with 3 columns. So we can get away with using variables to store those values. So, so basically, this is the tuple unpacking way. We fetch things, and then we identify the columns that we need, and then we unpack them into a bunch of variables, which we'll play with later. So I think we have seen this before. So we load them nicely into an F string, and then this is what we got. And with dictionaries, the print statement will be easy. Well, from here it's not really looking like it's easier, but we save the hassle of defining all these variables to unpack them. So now we can treat a row as just one object, or we can treat it as an entity, which is the way we view it at the very beginning stage of database design. We treat them as entity relationship diagram, and we map them into tables, and now we map them back to Python, where it is one entity again. So so conceptually, this makes more sense as well. So the only difference is that is the way we define the cursor. We need to make sure that we need to say cursor factory is the real dictionary cursor, and in the end, it will return a dictionary object for you to play with. So row will be a dictionary, and you can use them like this. Okay, so the advantage is that you don't need to remember the column order, and if the column order ever change, it does not affect you, and you can access columns by meaningful names, and it is kind of like self-documenting code. So that's a small tip that you could probably benefit. Let me show you another example where we need to list all subjects from here. So basically, the difference from before is that now we are using fetch all instead of fetch one. So we define the cursor the way we did, and then we use fetch all. In the tuple unpacking way, we define these variables in the for loop, and then we can use them within the for loop like this. And with dictionaries, it's the same thing. We can, instead of saying that row equals cur.fetch1, we're saying that for each row in cur fetch all, let's do this. So within here, each row is treated as a dictionary representing each row. So for each row, we have a dictionary built for that row. And we can basically use that dictionary in a kind of object-oriented way. So the end result should look the same, but the way we code them up is slightly different. It looks like the second way is we end up writing more code in the second way when the table is not super complicated. But the point of the second, with the dictionary-based way, is that it's more robust when the table is like huge. So if you have like 100 columns, then this line will get to like a point where we cannot write it in one line anymore. And then when we have 100 columns, this will stay the same. So we'll always build a dictionary for each row, and then we'll use that in this way. So the second approach, the dictionary-based approach, looks like it has slightly more code when the table is not huge, but is more robust when the table gets more complex. So basically for simple queries, we have 2 or 3 columns, we can use either. Tuple unpacking is fine. We're only working with a couple of variables. And for complex queries, if you have like 6+ columns, then you lose track with what variables each which, then you want to use dictionaries that is cleaner. And now we can illustrate this using a more complex example. So imagine we have a complex series with many columns. I think we have mentioned this point many, many times. With tuples, it will be very confusing because we have many. With tuples, it's very confusing because we have many columns in the end result. And with dictionaries, because the dictionary stores not only the values but also the column names, is easier, and we don't have to count all columns in the result. So you can kind of play with that after class. We have provided the database as well as the code. And I think we have made enough point about when to do what. So, so far we have looked at how to run one simple SQL query where it's a fixed query. So far we have done like select everything from subjects where and then we're not really inputting any parameters to change the filtering. And the more useful way to use cursor.execute is that we want to make it like a parameterized query where we can change the SQL statement on the fly by changing the values that we inputted into the placeholder. So here we can see that instead of running a fixed query, we can run a query with values inserted. So this is much more powerful than just a fixed query. A fixed query is just kind of like a view where we're getting this information, and then we can't really change what we're getting from PostgreSQL. And a query with values inserted is kind of like a function where you get to change the input value. So let's say that today you want to find John's favorite beer, and tomorrow if you want to find Jerry's favorite beer, you can just change that value, and then you get to change the SQL statement that's fed to PostgreSQL. So this is how you can run a query stored in a variable. So you can first define a pattern, and then you can execute using query and pattern. So let me do this. Let me talk more about the safe practices and the bad practices, and then we can do some demonstration, and then we'll know how we can put parameters into SQL statement. So SQL injection is probably the one thing we want to avoid as database developers, because other security concerns should already be handled by the SQL engine. So basically we have access control, we have transaction control, and pretty much everything else is handled by SQL itself. And our responsibility is to write efficient code and to write safe code so that SQL injection don't ever happen. So the following ways are very dangerous if we just use an F string to make up the SQL string. So if you use an F string where we don't really check what the value is and we just go ahead and execute it, then it becomes super dangerous, because if the value is now one semicolon drop all tables or list all tables, then people playing with the database using our interface can actually change our database, or they can see every table, the data in every table. So that's like a major leakage from our database. So that's not very good. And the safe approach is that we want to use parameterized query, where the query is defined as with a placeholder, and then we can put both the query, which is like a pattern, and then the input parameter in the execute command. So in this way, CyclePG2 will check the validity of the input parameter before executing it. So if you put something like one dropped all table, then it will fail. It will refuse to execute that SQL query. So, so the gist is we never want to build SQL with pure string concatenation using plus. So in Python, you can do string plus string as string concatenation. We don't ever want to do that for SQL, and we don't ever want to do that using F string. So we always want to use parameterized query like this. See if we can have a demonstration. So we should have a way to demonstrate this. Get out of here. Okay, go to week 5. Okay. So we have two scripts called SQL injection setup. Let me see what data that we're looking at. So we're looking at a table called R, and then we're inserting 3 rows into this table. So this table is, let me see, I may have put it into the same my database table. Let me look at my database, my DB, and let's look at R. Okay, select everything from R, select everything from R, and we got apple, banana, and cherry. So this is the very simple table for us to play with. And let me get out of here. Get out of here. And let's see what we want to check for SQL injection. So we're going to demonstrate 3 dangerous ways of writing SQL, and then we're going to demonstrate the safe way, and then we're going to compare them and see why the safe way is rejecting SQL injection. So the first way is, so all of these functions, they are playing with the tables that we have just defined, which is R with 3 tuples, apple, banana, and cherry. And the first one is we could use the app string to make the SQL statement. So we can define it as this, and the input value is just we can use an f string like this, and then we can directly execute this, directly execute it using the cursor. So note that we are not checking anything, and we are making the SQL query, we are making the SQL statement before we feeding it into cursor execute. So basically, at this point, this f string is fixed. There's nothing else we can do at this point, and the cursor will basically execute this query no matter what. So this is the first method, and the second method is string concatenation. So in Python, we get to do this is a very common way of doing string concatenation. We can use plus to add two strings up to do string concatenation, and the same issue with the previous method. We are not checking anything. We feed it directly to cursor execute, and then we're getting the result. And so nothing is checked in here, nothing is checked in there, and everything is fed into cursor directly. And the third dangerous method is we're using a percentage formatting. And so basically, we're using Python's percentage formatting to do string substitution, and basically we substitute a value into the string. This is just kind of like a variant of the f string that we talked about in the first example, and we just feed the whole thing into cursor execute as well. So nothing is checked. We're not checking anything. We're just basically making a string and then feed it into there. And the only safe method is that we're doing the parameterized query, where define the value and we define the query type. So the query is defined like this, and then the value is something that the value is basically a parameter, and then we run the query like cursor execute query and value. So in this case, it will check the validity of this input parameter, and if it's good, then PostgreSQL will go ahead and execute it. If not, it will say dangerous. This is a SQL injection attempt. So let me run this script and let's see. Let me run this script, SQL injection demonstration. Yeah. So I need to actually put something in here. So first, I'm going to put 1 in here and see what they're doing. So here, we're printing out the actual SQL query that gets executed. I think we did it, we basically printed out the SQL query, but we can also get it from cursor.mongrify to get the actual SQL query. So here, I think we're just basically printing everything out. In the third method, I think what we could do is we could use cursor.execute. We change this to mongrify, and then we can print the actual SQL script, SQL string as fed to PostgreSQL. So when it's 1, because this is not a malicious attempt, everybody is selecting from the table where the A column is matching 1. So we're matching the ID to 1, and then we're all getting the Apple row. So that's good. Now let's check something else. Something else we can check is that, what if the user put 1 or 1 equals 1? So let's see what that happens. So when this happens, so this is like a conditional. When we have like 1 or 1 equals 1, if you know anything about conditionals and Boolean operations, you know that 1 equals 1 is always true. So if one of the conditionals is true in an OR statement, then it's always evaluated to be true. So basically, you wanted to select just one row matching the ID, but now if you do that, you ended up returning all rows in that table. So basically, you're leaking unnecessary data to them. So if you're doing this, if you're doing this, the third method will reject it because, for formatting issues, because the quotes are not escaped. So that's the bad part about using percentage formatting. And if you're using f-string or string concatenation, it will basically bypass it. It will basically run this query, which basically evaluates to true for every row, and then you're just returning every row, which is not what we want. We only want to return the apple row. We ended up returning apple, banana, and the cherry. So we're leaking the whole. It's kind of like when we are trying to find if a member is active in the Medibank database, we ended up leaking all members' data. I think this happened like a couple of years ago. Our Medibank data are all leaked. And maybe they had a SQL injection, who knows. And the safe method, our parameterized write query, it will reject it, and the transaction is aborted. Let's look at another example. So if you're trying to drop the table, and let's see whether we're allowing it to drop. So if you put a semicolon after 1, then from PostgreSQL's perspective, this is an end of a statement, and then it will treat everything before that as one statement, and then it will start to execute another SQL statement, which is drop the table. So if you do that, let me see who is going to survive and who is going to be fine. So if you do that, the first method, second method, they say no results to fetch because they dropped everything. And in the parameterized query, this should be corrected. This should be prevented, and the transaction will be aborted. So you can play more with this at home. We'll release the path to all these files after class. So the take-home message is that when you're writing SQL queries in CyclePG2, don't ever use normal string concatenation with plus. Don't use f-string to write the SQL string alone, and don't use the percentage sign to do formatting. We always need to use parameterized queries so that CyclePG2 can check whether the input is legitimate or not. So the reason why this is prevented is that CyclePG2 have two steps to ensure that this is safe. The first step is that they send the query template to PostgreSQL, and then they send the parameter value separately. So in this way, we get to check whether that parameter is legitimate or not, instead of saying a whole SQL string. So whenever you're sending a whole SQL string to PostgreSQL, then there's a risk of SQL injection. Like you could end up showing unnecessary data to the client, or you can end up actually modifying the database that should not really be modified. So imagine you're trying to run a simple query and then the whole table gets dropped. So that's not very safe. That's enough with SQL injection. So SQL injection. So the reason why we haven't really talked too much about database security is because I feel like this is the only thing that we should be aware of and we should control on our end, and all the other security stuff is handled by PostgreSQL itself. And now let's go through a couple of more exercise on a uni database. So this is a simplified university database, and we're going to practice our pattern. We're going to connect to the database. We're going to execute a predefined SQL string. We're going to factor results. we're going to do something, and we're going to close the connection. So we're going to use Python and CyclePG2 on the uni database. Let me see what whether we have the database. Let me see what database. I feel like it's also stored in my DB. So we got people's table, students table. Let me see that. Yes. Subjects table, terms and courses and course enrollments. I think we played with this a couple of, like last week or something. And for every table, we need to define the primary key. This is the most important part of the table. And then for courses and course enrollments, we need to define a couple of foreign keys, which allows you to fetch information from other tables. So now we need to do 5 exercises. If we cannot get through all of them, then you can play with the rest in your own time. We will release these files. So first, what we want to do is that we want to get a list of subject codes and names. So before we get to do it, let's think about how we can do it. So just like we solve a normal SQL question, we want to identify what tables do we really need. So if we just need one table, then we just do while select from where block, the good old select from where block. And we just need to be careful about what we put into the where clause, and we need to be aware of the size of the number of columns in the end, and then we can decide if we use tuple unpacking or if you're using dictionary-based unpacking. And I think for most of the exercises here, we're not working with super huge tables. So the most we got is like 4 columns. So we can get away with not using the dictionary-based approach in here. So the first exercise, we need to get a list of subject code and names. So obviously, we need to look at the subject table, and that's it. So in the subject table, we need to run the query, select code and name from subjects, and then we need to do we need to use a cursor to fetch all result, and then we need to print probably the columns index as 1 and 2. So or you can use variable unpacking. So you can basically, we are only fetching code and names, and then we can use variables to store them, and this will be pretty straightforward. Let me get out of the database first. Get out of the database. Okay, I think it's easier if we just use a Python shell. Okay. So first we import CyclePG2, establish a connection mydb. So this is where people get wrong a lot of times. So please remember, put database name equals before your actual database name. And you need to, so here, because we're planning to use variable unpacking, we don't bother with importing the dictionary extension because we only have like a small table. So this is fine for this exercise, and then we can just execute this. We can execute this, and we can fetch all of them and print them out. And after that, we can close the cursor and we can close the connection. So I'm not going to close the connection now because we're going to demonstrate a couple of more exercises. And the second exercise, we need to get a list of subjects offered in each in a given term. So in here, it's getting slightly more complicated because we're expecting an input parameter. And let's look at what tables do we need to look at. So we need to get a list of subjects offered in a given term. So in a subject, it has subjects is only storing subject-related information, And how do we know if a subject is offered in a term? Well, it looks like we need to look at 3 tables. So we need to look at the subjects table, we need to look at the terms table, and we need to look at the courses table, because a course is basically a subject offered in a specific term. So a course is kind of like a man-to-man relationship between subject and term, and subject is referencing subject's ID, and term is referencing term's ID. So at the end of the day, we need to look at all these tables, and let's just look at how we could have done it in SQL, and then we can just use that SQL string to make our CyclePG2 program. So we want to get a list of subjects offered in a given term. And how do we identify a term? I think a term should have a name or something. Let's look at, I think I should have another shell or something. So this is not, get out of here, PSQL my DB. Let me look at the subject names. Subject names, we have 3 courses. And what about terms? I think term has their own names as well. So terms have their own names. And to uniquely identify a term, you probably need the ID. And we're only looking at 2 terms here. So basically, what you need to do is that you need to join these 3 tables. You need to join subject tables, terms tables, and course tables using these primary foreign keys. And then you need to make the input term as a parameter. And you want to use a parameterized query here to get all of the subjects matching that criteria. And in the end, you just want to print all of them. Let's look at term is. Let's run this SQL query first and get the hang of how we can how this is actually mapped into CyclePG2. So what we're doing here is that we're joining subject and courses, and we're matching the courses term and courses. Let me see if we should input a course term ID or a term name. So let me see, courses. Okay, so basically term, we only have like 2 terms. We have term 1 and term 2. Okay, so basically we have different courses, but the only terms that we're considering are term 1 and term 2. So if we put term 1 here, it will give us COMP3311 and 1511. And if we put term 2 here, it will just give us COMP3311. So 3311 is run twice every year. And obviously, this term will be an input parameter, and it will execute it like a parameterized query. And in the end, if you put 1, you should be given 2 courses, and if you give 2, you should be returned 2 courses. Let me run this Python script again. I think it's exercise 2 or something. If you do 1, it will return you 2 courses, and if you do 2, it will return 1 courses. So that's I guess the most important part about this construct is that you need to first figure out how to answer this question in SQL, and what information do we need from SQL, and what do we ask from SQL. So what we could have done is that you could have asked, hey, we want everything from subjects and we want everything from courses, and then we do the join in Python. That will give you the same effectiveness, it will give you the same result, but it's a bad practice because you ended up fetching more things than you need. So you always want to apply as much filtering as possible on the database level, and so that the transferred data has a small size. So you don't want to transfer a huge amount of data and you only want to fetch the data you need from the database, and then you can just apply your final touch in the application layer. And in this case, we're only printing them, but you could obviously do more complicated computations if you want. And I think we probably need to do a demonstration of Mongrify to actually show what gets executed here. Let me show you another. Let me go through another exercise. If you have time, we can do a Mongrify example, because Mongrify is super important and super useful for debugging process, and it allows you to see what the actual SQL code is fed into PostgreSQL. And what we also want to do is that we want to get a list of subjects whose codes are matching a pattern. So now this gets slightly more complicated. The input will be a pattern, and we're assuming that is a regex pattern. And the good thing is that we're probably only looking at the subjects table. Let me look at the subjects table. If they have subjects. Okay, so we have the subject table, and probably we're going to match the code. So basically, we could be asking, give me all of the COMP courses, give me all of the math courses, and then it will match based on the pattern. So give me a list of subjects whose code match a pattern. The SQL part of this is very easy. You just select everything from subjects where code matches a pattern. Let me demonstrate that as well, and then I think the input pattern should be. It's actually much easier than a regex pattern. Because the regex pattern is very hard to fed into here. So we're just gonna show like what courses are COMP courses and what courses are math courses. So basically, this is the SQL code underneath, and you need to input the pattern as part of the input parameter, and it will be the first argument, because the 0th argument is the script name itself, and the first argument will be the actual argument you put in there. And it will execute this in the parameterized query way. So note that the query body as well as the parameter are separated, which means that CyclePG2 are treating this as a two-step process. They're sending the pattern to PostgreSQL, and they're also sending the parameter to PostgreSQL. So they're never sending the whole thing to PostgreSQL. So what if I think to demonstrate this using Mongrify, I think we're better off with the Python script. Let's just demonstrate this in Python script, Python shell. So let's just import all these, and we're gonna say that pattern is COMP, everything starting with the COMP, and we're establishing our connection with the database, and then we're setting our cursor, and then we can execute this. And if you really want to know what gets executed, I think this is where you can see why Mongrify is useful. So Mongrify, Mongrify is returning you the exact SQL code that is fed into PostgreSQL. So this is super useful when you're trying to figure out what is the end result of our execute call. So before you do things like this, you can basically Mongrify it, and then you can say, okay, we're selecting code from subjects where code are like everything starting with comp. And then you can copy that into a PostgreSQL shell, and then you can run it there. And if that runs, then it means this should run. So we actually have it running already. So that's just we're just going to fetch the result into some placeholder. And in this case, we're just going to get all of the rows in here, which are all of the comp courses. So the takeaway message is that this is super helpful for you to understand the underlying SQL code you're sending to PostgreSQL. So before if you think that your cursor.execute has some issues, and then you should probably run this to figure out, to check what is actually fed into PostgreSQL. And you can copy that into PostgreSQL shell, and if that piece of code works, then most likely your execute is going to work. And if that doesn't work, then it means that you have some issues, probably from the SQL body here. Okay. Let's just try to do another exercise, and the other ones you can probably play with them at home. The fourth exercise, let me see. What is the fourth exercise? What we want here is that we want to display information about the subject given is code. So, so basically, we want to know about, get out of here, get back to the database. So if we want, so basically, for each code that are given, we need to know the information like what is the course name and how many of units is this course. And so basically, this looks like a one table query. So we're going to use subjects table. We're going to match the course code. And the course code is going to be the input parameter. And we're going to use variable unpacking in the for loop to store those results. And in the end, we're going to print them out. So none of these examples involve, note that none of these examples involve the dictionary-based method. You'll probably get to use that when you're doing your assignment, because you could be looking at much larger tables here. So let's demonstrate this and call it a day. So let me go back to the Python shell. So just like, so in Python shell we can, okay, if we're doing it in Python shell, we should probably not, we should probably give it a course code. So let's just do COMP3311. So code is going to be 1511, and we're going to establish a connection to the database, and we're going to, so before we execute it, let's mongrify it and see what. So let's just do mongrify. Oh my God, mongrify. Okay, so this is the SQL code that's actually we're going to fed into PostgreSQL. Let me go to the SQL shell, and then execute that. Don't forget the semicolon, and then it will give us all information about COMP1511. So which means that this is a legitimate SQL statement. Let's go back and execute that. So we did everything in here. We need to do code is COMP1511, and we have to establish a connection. And now we can safely execute this because we know that the underlying SQL is actually what we want. So now the cursor will be set at the first row of the result. And now let's just, we're only fetching one of them, so let's just fetch that. So let's just print the end result. So here we're using indexes, but obviously what you could have done is that you could do a variable unpacking. You can say code name UOC equals fetch. So let's just do that. So code name UOC equals fetch 1. Okay. Okay, so now it's fetching a none because we have already fetched this before, so we got to execute it again to make sure that it works. So let's execute this again, and now let's fetch 1 again, and wait, that's not how we wanted to fetch. Let me do this again. So we need to execute this again, and before we do the fetch, we need to put variables in here, and then we do fetch 1, and then everything will be unpacked to code name and UOC, and code will become 1.1, name will be programming fundamentals, and UOC will be 3. Okay, so just go ahead, when you're back home, just play with these examples and really learn how we unpack things in different ways. We have looked about 3 ways we can unpack things using row indexes. We can unpack things using these variables, and the most robust way we can unpack things using a dictionary. Okay, that's it for today's lecture. And if you got a question, I'll stick around to answer some of your questions about today's lecture or about the assignment. Thank you. A0, terminate. Good.